All right, hey everybody, welcome back from a couple snow days. We're going to get started right away here with 8-8. This thing we're learning today, it's called the difference of squares. So notice that we're using the word difference and we're using the word squares. If you remember, difference means like subtract. And squares, when we're talking about squares in math, yes, I mean it means like the shape of square. But what it really means more is that like the number 16 is the same as 4 times 4. We call it a perfect square because 4 times itself, we call this 4 squared. It's 4 times 4, 2 times, is 16. 16 is a perfect square. 16 isn't the only perfect square. 25 is also a perfect square because 5 times 5 is 5 squared. So 25 is a perfect square. 36 is a perfect square. 6 times 6, 6 squared. Okay, so difference of squares. So we're subtracting 2 perfect squares. That's what we're talking about today. Before we get into that, I'm going to try to zoom in here so you can see this a little better. Over here on the review section, I want you to just kind of fill this out. If you remember, we've done something called FOIL in the past. My math teachers hated the word FOIL. But the FOIL method, or the distribution method, is where you're multiplying a times a squared, a times b. Notice this is a times positive b, so this will be plus ab. And then if we are adding together these other numbers here, we would have negative b times a. So that's negative, instead of writing ba, I'm going to write it ab so that it's the same, it looks the same. B times a is the same as a times b. And then negative b times b is negative b times b, negative b squared. As you simplify this, you might notice that these terms in the middle here, the AB plus AB minus AB, well, if you had like plus 5 and minus 5, it would just go away, right? So plus AB minus AB, this is like if I throw you the pack of Skittles, but then I just take it away from you. I'm giving you something, but then I'm taking away the AB. This just goes away. So these cancel out, those middle terms. So that leaves us with, as a final answer, a squared minus b squared. So this whole rule here gave us that a minus b, this part right here, a plus b, is equal to a squared minus b squared. We could say that based on what we just did right here in the math we just showed. What we're talking about today is where you start out with this finished answer, this finish line. Let me find a good color here. I don't know. Let's go with this one. This finished answer. Everything I'm going to show you looks like an a squared minus a b squared. Notice how this is 2 square numbers. These are both perfect squares. Perfect squares. And hey, you guessed it, difference of squares. We're subtracting them. That's where the difference comes in. No matter what I give you with the a squared minus b squared, you can always rewrite it as, you can factor it. We've been talking about factoring like for the last week or so. I mean, you guys are probably getting sick of it way more than I am. But when you see something like this, it can be factored into a minus b times a plus b, based on the math that we just did the same way. This is the power of an equal sign, by the way. Because we know this is true, this will happen every time, we can just flip it around. And if you start with the answer, it can lead us to where we started. If you start at the finish and walk backwards, you'll make it to the start. Okay, so here's a few examples. Factor the difference of squares. This binomial expression, that's just a fancy way of saying binomial means 2 numbers. expression means that there's not an equal sign, so you have two numbers, binomial. It's called the difference of two squares. Okay, we've already talked about that. Cool. I'm going to highlight it though because that's an important vocab word, difference of two squares. The following pattern shows how to factor the difference of squares. This is exactly what we just did right here. So difference of squares, this is just in a nice box. I had a squared minus b squared, that's what we're starting with right here, is equal to a minus b times a plus b, or you could write it in the other order where you have the plus first. A plus b, a minus b. It doesn't matter either way. Okay, so what they want us to do down here is factor the polynomial. So what I first need to do is figure out, okay, well, I need something. In order to use this perfect square thing, I need an a squared minus a b squared. So if I'm trying to find a squared minus b squared, the first thing I check for sometimes is this minus sign. And good news is that this is a minus sign. So my a value, my a squared value is actually equal to x squared. It's this first term right here. I could say that my b value, or b squared, is 81. So I have x squared minus 81. The problem is, if I'm going to factor this, I don't really want those. I don't want a squared, I just want a. To get a by itself, the opposite of a squared, you might want to write this down, opposite of squared is the square root. And that's this little radical. Remember the radical symbol we talked about? If you had me as a teacher last trimester, we talked about a radical. And I had a big, huge one in my room that you could stand underneath, kind of like that house. So, for example, if I took the square root of 16, remember 16 is a perfect square. So if I took the square root of 16 in my calculator right here, the square root, if you click the second button, and then go down to the squared, it's that little tiny radical. Square root of 16 is 4. Hey, well look, the square root of 16 is 4, just like what we did right here. 4, because 4 times itself is 16. If I did the same thing, second, I'll show you again. If you didn't catch the square root, you might want to look right now because I'm going to show you the square root button. Square root 1625 equals 5. So the square root of 25 is 5. All right, so here I want to find not a squared, but I want a. So a is equal to the square root of x squared, which in our case, the square root of x squared, those cancel each other out. We haven't talked too much about that, so it's okay if it doesn't make sense totally right now. So the a value would be x. The b value, so if I start b is the square root of 81. If I type that in my calculator, the square root of 81 is 9. So now I have two numbers. I have x and I have 9. To factor this completely, I'll write my final answer here in red. I'm going to have x minus 9 times x plus 9. That is based on what we did right back up here. I started with x squared minus b squared. So x squared minus 81. I found what a and b were. So a is just x, b is 9. And then I put them in the parentheses. A minus b, x minus 9, a plus b, x plus 9. That's my first example. I'm going to pause my video just for a second